Good day, students. Welcome to mathgotserved.com. In this clip, we're going to be taking a look at line, rotational, and point symmetries. We're going to be looking at what these terms mean. All right, so let's take a look at the first one. The first type of symmetry we're going to look at is known as line symmetry. You can also think about it as a fold line. A figure has line symmetry if a line can split the figure into two identical images mapped onto themselves by a fold over that line. Okay, the line of symmetry is like a mirror. So just to illustrate what the line symmetry looks like, so if you see this object right here, can you visualize a line that causes this object to be split into two identical parts that are mapped onto themselves when you fold along that line? Fold or reflect. So there goes the line of symmetry right there. All right, so if you fold the left side and the right side of this upside down arrow along that line of symmetry, you can see that it's going to overlap perfectly on itself. That's an example of a line of symmetry. All right, so it doesn't have to be vertical, it could be in any direction whatsoever, as long as it splits the figure in a way that fits the description right here. All right, the next one is the rotational symmetry. All right, as the name indicates, there's some kind of rotation happening here. For rotational symmetry, a figure has rotational symmetry if it is mapped onto itself, basically overlaps with itself perfectly by a rotation less than 360 degrees about a center point. A good example of that is a square. So if you take a look at this square, if you rotate it by, let's say, 90 degrees, it's going to overlap itself perfectly if you rotate it about its center. All right, so let's take a look at a visualization that can help us to understand the concept of rotational symmetry. All right, so if we take a look at this square right here, all right, if we rotate this square by 90 degrees, see that angle increasing like that, 90 degrees perfectly. Okay, what do you notice? It's mapped onto itself perfectly. All right, so remember, if the rotation is less than 360 degrees and it causes the figure to be mapped onto itself, then that symmetry is called rotational symmetry. All right, we can also keep on going. Let's try another multiple of 90, let's say 180 degrees. Bam. It also gets mapped onto itself. So this one has a higher order of rotational symmetry. All right, so the last one to look at is a special case of rotational symmetry that is called point symmetry, okay, or upside down. Think about upside down. A figure has point symmetry if it is mapped onto itself by a rotation of exactly 180 degrees. So the sample figure is right here. If we rotate that figure by 180 degrees or flip it upside down, rotate it upside down, you're going to have exactly the same figure. An easy way to do this to check for point symmetry is to get the object on a sheet of paper and then rotate the paper upside down 180 degrees. If you have exactly the same figure that you had initially when you had the right side up, then you have an a point symmetry situation. Alrighty.